So hello and welcome everyone to our weekly session titled Latest in Bitcoin Tech, where we go through the Bitcoin Optech newsletter to discuss the latest news happenings and releases and documentation updates in the world of Bitcoin and Lightning primarily. And this week as well, we have a news section and we have a Q&A section, which I believe is a monthly section. And then we have releases and release candidates. We have notable code and documentation changes, which are a part of the week letter every week. This week's newsletter is pretty expansive. It has 10 Stack Exchange questions and answers. And I think it has a lot of notable code and documentation changes as well. 3, 4, 5, 6, 7, 8, 9, 10, 9, I think. All right. So we definitely will not be able to finish the entire letter. We'll cherry pick things and we'll try and discuss them. There's only one news article, which I feel if time permits, we should come back to it at the end. Because firstly, it has to do with the Lightning Network and I see a few new faces. So I prefer delaying anything that is related to Lightning Network and talk about Bitcoin as much as possible so that everybody can relate to it. And also because this is it deals with the research. The research paper is not even ready. It's work in progress, so we don't have a lot to discuss about. If time permits, we'll just skim through the motivation of the researcher. We'll start this week's newsletter with the Bitcoin Stack Exchange Q&A. We have 10 of them. So let's start with the first one. Before that, let's just go through the preface of the newsletter. This week's newsletter summarizes research into estimating the likelihood that an LN payment is feasible. Also included are our regular sections with descriptions of popular questions and answers from the Bitcoin Stack Exchange, announcements of new releases and release candidates, and summaries of notable changes to popular Bitcoin infrastructure projects. I think somebody has unmuted themselves. Can everybody please mute themselves? All right. So the first question is, how is the progress of initial block download IBD calculated? Peter Wooler points to Bitcoin Core's guess verification progress function and explains that the estimated total transactions in the chain uses hard-coded statistics that are updated as part of each major release. Most of us who have run or who run their nodes know what IBD is, what an initial block download is. When you start a Bitcoin node from scratch, it needs to catch up with the active chain tip for which it queries its peers, and the process of that node going from Genesis block, which is hard-coded in every implementation of Bitcoin. The process of going from the Genesis block to the active chain tip is known as initial block download. So during the initial block download, your Bitcoin node validates all the transactions and validates all the blocks, and then builds upon those blocks till it reaches the active chain tip. That's what the IBD is. It might take anywhere from 1 day to even 3 months, depending upon your bandwidth and your hardware specification. We'll look at the answer. We'll read the answer first. So the question is, how is the progress field of Bitcoin Core's synchronization initial block download debug logs calculated? All right. So if you're running a node basically from a package software, you will have a dedicated file known as debug.logs. Okay. So when you open that file, you will see logs basically coming out, as the name suggests, from that file, indicating you about the current status and relevant information pertaining your node. And if you are building and compiling a Bitcoin node from source code, then you'll see all of this in your terminal by default. Okay, so this is how it looks like. Basically, if any of you have done an initial block download, this is how it looks. This is the information that your logs share. All right, the time and the new best tip, the height, which is the block index, etc., etc. A lot of things. So the question is about progress, and most people who download blocks, who run their nodes and go through IBD, this is the most significant piece of information that people generally look up to. This indicates how far you've reached during your initial block download and how much further you have to go. Okay, so when it says 0.93, it means that approximately 93% of the blockchain has been synced. All the transactions in the blocks have been validated, and approximately 7% is remaining. So the questioner asks, how does your node get this metric? Like, what is the process to determine what this metric is? How is the progress field calculated? What are its possible values or units? What is the function in Bitcoin Core that does this calculation? The question has been answered by Peter Wooler. The progress value is the ratio between the total number of transactions in the currently validated part of the active chain and an estimate for the total number of transactions in the chain. The estimate is computed based on statistics that are hard-coded in the software and updated for major releases, including a known point in the chain at a known timestamp, with a known number of transactions and a predicted rate of transactions per second afterwards. So basically, this is the ratio. And how is this ratio calculated? This ratio is calculated using two pieces of information. The first is the number of transactions in the currently validated part of the active chain. Okay, so the number of transactions that have been validated by your node. When your node is going through an IBD, the number of transactions that your node has validated is taken into consideration. Okay, that is one metric that you need, and the second one you need is an estimate for the total number of transactions in the chain. Okay, so now what's something that I found really striking is that it did not say that the current number of transactions in the Bitcoin network. It said an estimate for the total number of transactions. So there's a hard-coded number. Okay, it's a hard-coded number which is updated with every major release of Bitcoin Core. When that release is published, at that point in time, what was the Unix timestamp? What were the number of transactions that were validated? These values and a few other values are hard-coded in Bitcoin Core, and they are used as a parameter or a metric to determine the progress. We look into the code to try and understand it better at a higher level. It is a dimensionless unit. It doesn't have any dimension. It's not in percentages, nothing. Okay, it's just dimensionless. What else? And the third question is, where exactly is this computation done in Bitcoin Core? So he's given a link, okay, and that link takes you here. I've opened it in VS Code so that we can go through the documentation. This is that function. Okay, you'll find it in validation.cpp. Okay, I believe it is not in consensus. It is. Yeah, it's Bitcoin validation.cpp, src validation.cpp. This is the function, guess verification process. This is the function that does the computation that lets you know how much progress your node has made in the initial block download. Okay. So you have a reference. Your p index is a reference to C block index, which is a class. Okay, and what this class does is that it pertains information regarding the block index. So your p index is a reference which is referring to, it's a pointer, sorry, not a reference. I take my statement back. It's a pointer. It's a pointer that is pointing to the current block index. Okay, and data is a reference. Okay, data is a reference to this struct called a chain tx data, which has some information. I think I have it open over here. Yeah, this is okay. So it contains three pieces of information, as you can see. Okay, one of them is the Unix epoch time. Okay, the second is the number of transactions validated, and third is a DTX rate, which is the rate at which the transactions are getting validated. So this information is hard coded. Okay. So the version of Bitcoin Core's implementation that I have opened right now, I believe it is 27. So when this version was released at that point of time, this was the okay. Look at it on Google. We'll see that this has to be 2023 or 2024, something like that. I'll just copy and paste that. This value is hard coded, and you see 27 January 2024. So this was when our Bitcoin Core's latest major release was launched. Okay, so when major release was launched at that point in time, what was the time and what were the number of transactions that were validated are hard coded in this struct, which is chain takes data. Okay, and you use this information to calculate the progress. Okay, so you calculate the number of transactions that have been validated by your block during the IBD, and the number of transactions that have been hard coded or were validated at the time the latest major release of Bitcoin Core was released. Okay, and how do you use those two pieces of information? This is primarily the formula. Okay, this is primarily the formula. So basically you have a double FTX total. Okay, now how do you calculate this FTX total? There can be two situations. The first situation can be while you are going through the IBD, the number of transactions validated by your node are less than the number of transactions which were hard coded in the code base. Just now we saw wherein how the number of transactions are hard coded. Okay, so in that situation the if clause is true. The if clause is true. Okay, so the number of transactions P index is the block height. So the block index. So at the block index at which your node is, you see if the number of transactions are less than or equal to the hard coded value, then the if statement is true, and this is how you calculate FTX total. Okay, and if the number of transactions that your node has validated is more than the hard coded value, then the else block is true, and this is how you calculate. And once you get FTX total, you substitute it into this formula. Okay, and you have a limiting factor of 1, which gives you the progress. So your progress will always be less than 1. So there can be two situations. The first situation is the number of transactions that your node has validated is less than the hard coded value, which put its major release of Bitcoin. In that situation, this is how you calculate FTX total, and if not, then this is how you calculate FTX total, and then you substitute in this formula. You've already got FTX total from either the if condition or the else condition, and you have this second one, which is the number of transactions that are validated by your block, and then you limit it to a factor of 1. So this is how you get the progress broadly. All right, so that is the answer to the question. How is this progress calculated? We just looked into what this progress is, where it is, how it is calculated, which code snippet calculates it, whether it has any units, it doesn't have any unit, and yeah, this is the relevance of this metric that your debug log file will share with you if you're running a package software like a Start9 OS or an Umbrel or a Citadel, something like that. And if you've built and compiled Bitcoin Core or any implementation for that matter for your Unix or your Linux operating system or your Windows operating system or your macOS operating system, then you'll find this in your terminal. So this is the answer to the first question, which was what is the significance of this metric during IBD? How is it calculated, and does it have any units? Anything pertaining this?
Faisal, I just have a small question. So if you already have an else clause in the calculation, like you have to deal with a case where the IBD, the blocks that you download crosses the hard-coded value. So if that is the case, so why not use the else clause from the beginning? So what is the advantage of hard-coding something, and then after you cross the hard-coded block height, then you can start to calculate it dynamically. So I guess the else class does the calculation in some sort of a dynamic fashion. So why to start the dynamic calculation after the hard-coded part is?
Okay, yeah. Your question is here. Yeah, here we don't have any dynamic information, right? Yeah, we don't have any dynamic information. Here we have dynamic information, right? Because this P index is what we're calculating dynamically. This P index is what we're calculating dynamically, and here we're using all the data which is static. Everything is hard coded, right? I believe that because ideally, if you cannot use the same formula for both the if clause and the else clause. When you look at it, okay, this is my interpretation. When you look at it, it's pretty evident that you're not using the same formula. The formula is absolutely different, right? And that is because whatever your FTX total is, okay, it has to be within the bounds, this fraction always has to be within the bounds. So one reason that I could think of is that when it is below a certain hard-coded value, okay, this formula will always ensure that your result of this computation is always less than 1, okay, and when it's greater than 1, this computation will not ensure that it is greater than 1 if you use the same formula. So that is when you revert to the dynamic formula, okay. So to verify that, what you will have to do or what I will have to do is actually substitute values in C. Okay, prima facie, this is the inference that I could come up with. But to validate it, you will actually have to look at the hard-coded value and take some dummy values for p index, which is less than the hard-coded value, substitute it, find the value of ftx total, and then do that same for the number of transactions which supersede that hard-coded value, and then again find ftx total and then substitute in this.
Also, I think that if from the IBD, like from the Genesis block itself, if you try to calculate it dynamically, then you will not get a sense of true progress, is what I think. Like you could be, if in the case you have a fixed hard-coded block against which you can measure your progress. If that is not the case, then I think you will have to rely on whatever latest block that you get from your peers, and then do the progress computation. So that will
right
be quite
right, exactly. And the second thing is, Bala, that I mean you cannot use static data after that hard-coded value because you don't have any information, right? When I am releasing, let's say I'm a Bitcoin core developer, okay, and I'm releasing Bitcoin cores 27.0, okay, I'm releasing today, okay, let's releasing it on what was that date? I'm releasing it on 27 January. I only have hard-coded data up till 27 January. After that, I don't have hard-coded data, so I cannot use any hard-coded data to find the value of ftx total. All right, here's ftx total. So only till the IBD reaches that hard-coded value of 27 January, I can use static information, okay, hard-coded information to find ftx total. After that, I have no hard-coded data or static information. I don't know what is the number of transactions that have been validated. Okay, so I cannot use hard-coded data after that because I can't predict the data for the future. So at that point, I will need to dynamic data. Okay, because I don't know. See, here we dynamically fetching the block time, right? Here we have a hard-coded value end time because we know this is history, right? For history we know, but this is future. We don't know what will be the time. So here we are dynamically fetching the time of the future.
Yeah, that also means like if you are trying to do an IBD on a version that was released long time back, then you should not rely too much on your progress that is being shown.
No, I think it will still be because whether it's January 27, 2024 or January 27, 2023 or 2021, okay, once you've crossed the hard-coded value, it will retort to dynamic calculation, which will give you the correct answer.
Yeah, that's what I'm trying to say. Like if we are, say, for example, in trying to do an IBD on a client that was released 3 or 4 years back, then whatever progress that your IBD shows will be correct till you reach that hard-coded limit, and then it is going to move around a bit. Like you are not going to get some precise values, is what I am guessing.
I would disagree with that. Okay, so yeah, we can take it up later, but I personally would disagree with that because then it will use this get block time. Okay, then it'll use this get block time. So irrespective of whether it's the latest major.
The issue with get block time is that you are now relying on whatever the peer is sending you, and it might be the next block, or it might be 100th block from where you are now. So I think.
If it's the 100th block, I mean, your node will only build on top of the chain as long as the hash matches, right? So if you have block n and your peer is sending you n plus 100, you will not add it to your blockchain. You will only add it if it's n plus 1, right? Yeah, like the previous hash must match. If the previous hash of n plus 1 block should match the hash of n block, only then will you make it a part of your blockchain, and only then will your p index will point to the new block height, I believe.
That's right. Okay, I didn't think about that. Okay.
Okay.
Yeah, I have a question. Sure. How is the DTX rate calculated?
That is a question that even I had. It is calculated. See, we'll see first. We'll go to the docs. Okay. Let's see what it's the estimated number of transactions per second. Okay. I looked at this code slightly before coming for the session. Okay, so it says estimated number of transactions per second after that timestamp. Okay, so like we just now discussed that we have a timestamp which is hard coded. Okay. After hard coded time, what is the estimated time? What is the estimated number of transactions that will be validated per second is calculated. Okay. So I think if we go here. Okay, yeah. So after this time, what is the estimated number of transactions that will get validated per second is this metric DTX rate. Okay, and even I'm not aware as to how this is calculated. Okay, because nowhere in the code base at least it's mentioned. Let us see if it's mentioned somewhere on Stack Exchange DTX rate. It was not related to a specific question. That's why I did not spend too much of time with it. But if anybody is interested, then maybe later on they can have a look at it.
Yeah, because it is hard coded and we don't have any reference to it inside the code, I guess.
So this answer is also by Peter Wooler. Okay, let's just see. Okay, this is the timestamp. Let's assume this is the timestamp. Okay, the total number of transactions in the chain was this. So at this time, this was the total number of transactions in the chain. After the point in time, this transactions per second are expected. Okay, so here also is mentioned this is the expected number of transactions that will get validated after this timestamp. How do they calculate it? I am not aware. It doesn't seem that it's mentioned, at least in the code base. We can look into it. Whoever is interested, even I'll try to look into it, but right now I think we'll end up spending too much of our time. Yeah, so we can look into it and hopefully come back next Monday, whoever has the answer as to how. We know what this is. We know what this is now. Okay, it's the expected number of transactions that will get validated per second after this time. Okay, how do we calculate it? I personally believe that I could not come across how exactly it's calculated anywhere in the code base. Neither is it mentioned in the documentation. So yeah, maybe if we get time next Monday, we can come up with an answer and let's see if we can find out how this exactly is calculated.
Yeah, sure.
Yeah, and if somebody finds before that, they can even post it in the book for the in the chat group for the larger benefit of all the other members of the Discord server. So the next question is, what is progress increase per hour during synchronization? Peter Wooler clarifies that progress increase per hour is the percentage of the blockchain synchronized per hour and not an increase in progress rate. He goes on to note reasons why progress is not constant and can vary. Okay. Can anybody guess what this is? Because I'm sure most people have always misunderstood this. Even I misunderstood what this is. Okay, and I am 100% sure a lot of people understand what this is. So any of you who've ever done an IBD on a packaged software, okay, whether it's Bitcoin Core or on your Mac OS, on your Linux, have definitely seen this. Can anybody guess what this is? Or even from the screenshot, okay? So this chain has been synced up to this level 96.52. That is progress. We just now saw how progress is calculated, and then we always have this metric below it, 0.25%. Can anybody guess what this is? Any random guess?
The rate at which additional progress
should be the rate.
Sorry, somebody said the rate at which
subsequent progress is being made or estimated that it will be made. So in an hour, we'll go from 96.52 to 96.7977.
Okay, I don't have access to Discord's screen. So can you please mention your name if you don't mind, or your pseudonym? Sorry. The answer. Replete. Okay. Yeah, it's a pretty good answer, and I'm amazed that you got it right at the first time. Okay, Replete Sumo. Yeah, you got it right at the first time. I have gone through this process. I don't know how many times I've done IBD almost a dozen times in my life, and I always used to believe this is the rate at which your sync is increasing. Okay, so let's say in the first hour, if your blockchain sunk by 1%, in the second hour it will sync by 1.25%. I always used to believe that this is the what do you say, relative increase in the rate at which the blockchain is syncing, because the name is pretty ambiguous. Progress increase per hour. Okay, and even like I was hearing a certain podcast in which some Bitcoin Core contributors also believe that is what this metric was. But yeah, you're absolutely right. Basically means the amount of chain that will get synced in the next 1 hour. So after 1 hour, it should ideally be 96.77. That is what it is. Do you want to go through this entire answer? Let's see. To answer this question,
Sorry, if you scroll up, so then should the math add up with that last row where it says 14 hours? So it's 0.25 times 14 plus 96.52 should round up to about 100%, right?
Right. In the next 14 hours, you'll get done at this rate.
All right. Thank you.
Welcome. To answer the question, I believe you have progress increase per hour. 0.25% means that 0.25% of the blockchain is synchronized per hour, or that total from scratch synchronization, assuming the current rate is constant, takes, that is 100% divided by 0.25%, that's 400 hours. Okay, so yeah, that is what it means. Let's not go into the entire answer. I don't think there's any added information in this. Let's move on to the next question.
But this could vary depending on the progress or the speed of the processor, right? Because
it could vary every second.
Yeah,
depending on your bandwidth, on a lot of factors, it could vary every second. Okay, so if like what happens during IBD, if any of you have gone through IBD, okay, if you're doing an IBD and for some reason you lose contact with the internet, okay, and then you connect to the internet again, your progress, then it might even show from 14 hours, it might go to 6 months. Okay, then so from 6 months, within a few seconds, it'll go to 3 months. Within a few seconds, it'll go to 1 month. Within a few seconds, it'll go to 2 weeks. Within a few seconds, it'll go back to 14 hours. So it happens. It can vary every single second. Okay, so let's cherry pick questions because we'll not be able to cover everything. Signet mobile phones. I'm trying to skip questions that will take a lot of time to discuss, and that will also need a lot of context, like these ones. We'll have to go through what an X coordinate is, what a Y coordinate is, when we use X coordinates, when we use Y coordinates. So I'll try and pick questions which are like straightforward and also trivial. Mobile phone wallets. Merge lists 4 Signet compatible mobile wallets: Nunchuck, Lava, Envoy, and Xverse. So I believe the questioner asked. The question is, I have been using testnet with Bitcoin Core and mobile wallets from BitPay and CoPay using a testnet wallet. Testnet is currently broken and I need an alternative. I have discovered Signet and have a Bitcoin Core running testnet I could convert to Signet. However, I need to be able to send and receive Signet using a mobile phone. I know I need internet access, so I plan to move to AWS to make it more universally available. The question I have is this: will existing mobile phone testnet wallets work with Signet? Can Signet coins coexist with testnet? If I make a clean testnet wallet, can it receive Signet coins? So there is a questioner, basically he has been using testnet and he has some wallets in his mobile phone that support testnet. Now he is doing something on the Signet, so he wants to know whether the same wallets are compatible with Signet and whether testnet coins can be spent on Signet and vice versa. Are these two networks like mutually exclusive, or do they interlap each other? Before we begin, would anybody like to take a shot at what testnet is and what Signet is, and what's there are multiple differences, but what's the major difference between testnet and Signet?
Testnet is kind of an open testing network, like it is accessible to everyone, while Signet can be a private network, I guess. I mean, not exactly private, but like you can have more control over who can mine the blocks and who can connect to it, I guess.
Right, an authorized network, basically, like you can authorize. So testnet more or less simulates the main net. All right, like testnet also has this concept of proof of work. Just like how you mine blocks on the main net, you also mine the blocks on testnet. It's just that the mining difficulty is less. Okay, so it's more organic. It's not preempted. Whereas a Signet, as the name suggests, is an authorized network. Okay. So like you can create your own Signet and you sign to create blocks. You authorize blocks. Okay. On the testnet, the blocks are created by mining. by doing work, proof of work. On Signet, there is no concept of proof of work, correct? You just digitally sign and authorize the block. So every 10 minutes, you can digitally sign and authorize a block, and a block will get populated every 10 minutes if you want to. So Signet is like more controlled, it's less organic, it's more synthetic, and testnet is more organic. So testnet closely simulates the behavior of the main net, and Signet is more like an adiabatic network where a person or a handful of people have the authority to decide when the blocks will be populated. So that's the primary difference between Signet and testnet, and these are two different networks. Okay, so one wallet that is compatible with Signet might not be compatible with testnet, and Signet coins cannot be spent on testnet, and vice versa. So the questioner asked, are there any mobile wallets that support Signet? And there are 4 apparently. After asking on Twitter, I was informed that the following mobile phone apps should have Signet support: Nunchuck, Lava, Foundation, and Xverse. These are the 4 apps that, as per the Twitter users, support Signet. I'm neither recommending or endorsing any of these. I'm just relaying this information as a starting point for your own research. This was the answer given by Moch. All right. Let's move on to the next question. What block had the most transaction fees and why? So the questioner wants to know which block in the history of Bitcoin had the maximum transaction fee and what was the reason for that transaction fee. So Merch uncovers block number 4090008 with the most Bitcoin denominated fee. Okay, so this block had the highest Bitcoin denominated fee. And this block 818087 had the highest US denominated fee. That is, I believe, how much is this unit? 10, 100,000, 10,000, 3 million US dollars. Okay, and as you can see, this is an earlier block. Okay, so back then the price of Bitcoin was low. Okay, and even though I believe that here this BTC denominated is less than this BTC denominated, but despite that, here the USD denominated fee is higher because at the time of 40988 the price of Bitcoin was low, and at this time the price of Bitcoin, I believe, doubled, tripled, I don't know how much. Okay, so these are the 2 blocks, 40988 and 818087. Let's just look at the question or the answer. To this date, 2024-0531, the block with the highest transaction fees in Bitcoin has been block 409-008, which collected 291.533 Bitcoin in fees. This was caused by transaction such and such creating only one output worth 0.1 MB. And failing to collect the change while using 14 inputs worth more than 291 Bitcoins. So yeah, it basically, the person created 14 inputs with a value of this, okay, and just one output, and forgot to create a change output. So all the surplus amount was given to the miner as fee. And the block with the highest transaction fees in USD was such and such 818087, collecting 85.216 Bitcoin in fees at that time worth about 3189221. That's 3 million US dollar, which again was caused presumably by someone not collecting their change output in transaction. So both of these blocks, there was the common reason that such a humongous amount of fee was paid to the miner, and that was the people who were broadcasted that transaction forgot to add a change output, and all the surplus amount went to the miners because that is the implied fee. Okay, the input minus output is the implied fee that the miner gets if you don't have a change address. And recently I discovered this cool tool that I would also like to share with you all. I think it's called Bitcoin Chair. Block Chair, which has a lot of interesting filters for you to retain information pertaining multiple cryptocurrencies, but we obviously are interested only in Bitcoin. So we'll go to Bitcoin. So here you can put in a lot of filters and retrieve a lot of interesting information about Bitcoin. So if you go to, I believe, transactions, okay, go to transactions at blockchair.com. So it gives you a lot of filters. So you can go here and see which was the transaction in the history of Bitcoin that paid the highest fee. Okay, so I have removed all the filters. The only filter is transaction fee USD. So it should show me. Transaction fee USD. Yeah, here it is. This one, 3 million. Okay, it happened in 2023. That is December last year. This happened in November of last year, where somebody paid a fee of $3 million US. So this is the highest Bitcoin USD denominated fee that has ever been paid, and the reason was that no change address was added, and all the implied difference between the input and output went to the miner as the fee. And if you want to check the highest BTC denominated fee, then just click on BTC, come here, click on BTC, and click on USD. So this should now give you the highest BTC denominated fee. Here it is, 200 BTC, 291 BTC. And this happened in 2016, like 8 years ago, where 291 BTC was paid in fee. Okay, so yeah, these were the two blocks that paid the highest, or two transactions that paid the highest ever fee in the history of Bitcoin. One denominated in BTC and the other denominated in USD. Which one? Yeah, sure.
Just a small query. Like if we do any Bitcoin transaction, let's say during the UTXO consolidation, we provide all inputs, and the output will be only two, right? One is the fees, another one it gets back to, I mean, another UTXO will come back to us only, right?
Yeah. Did you say one UTXO for the fee?
Let's say in the first example at the block 409.08, if it has 4 inputs and one output being a fee, another output will be the remaining chain that will come back to us, right? You mean to say that whatever the remaining UTXO that has to come back to us, it went to the miner as well?
No, there will be no output for a fee. There are no UTXO created for the fee. The fee is always implied. Okay. So let's say you have 14 inputs of 1 BTC each. Okay. And now you want to consolidate all of them into one single UTXO, right? That is what you want to do.
Yes.
Okay. So what you'll do is you'll create one output of, let's say, I'm just giving imaginary figures, let's say 13.95 Bitcoins. Okay. And that 13.95 Bitcoin will come to you. What your wallet will do is your wallet will subtract the input from the output. Okay. So your wallet will subtract 13.95 from 14, and whatever is the difference will directly go to the miner. You don't have to create a specific UTXO for it. Your wallet software is designed in such a manner that it will subtract the input from the output, and whatever is the difference will directly go to the miner. So if you have 14 inputs of 1 Bitcoin each, and you have just one output of 1 Bitcoin, okay, the 13 Bitcoins will go to the miner if you don't have a change output. Like modern day wallets, most modern day wallets have a mechanism in place that by default they will create a change address for you. Okay, but other than that, you don't have to create a specific output for paying the fee. The fee is implied. It is just the difference between your outputs and inputs. So you will create just one output that will come back to yourself, and whatever is the difference between the output, the 14 inputs, and the one output will go to the miner.
Okay, I wanted to understand what is the meaning of this sentence, caused by a change output.
They did not specify a change address. Okay, so what I can do is, like for instance, I have 1 Bitcoin. Okay, out of that 1 Bitcoin, I want to pay 0.5 Bitcoin to you. Okay, and I want to pay 0.01 Bitcoin to the miner as a fee. Okay, so here I have to create two outputs. The first output will be 0.5 Bitcoin, which will go to you. The second output will be 0.4 Bitcoin, which will be changed, which will come back to me. And the difference, which is 0.01 Bitcoin, that is the implied difference that will go to the miner. For that, you will not get specific UTXO. Does that make it clear?
Okay, Faisal.
If you have any follow-up questions, please feel free to ask.
Yeah, so Faisal, so now you're saying in the current implementation, this kind of mistakes cannot happen.
It depends on implementation. It depends on wallet to wallet, which wallet you are using. But yeah, most wallets, what they'll do is they'll estimate a fee. I cannot say that all wallets are doing that. I don't know, but yes, most modern day wallets, they have a mechanism to estimate the fee. All right, they have either APIs, okay, or they have inbuilt algorithms that look at the mempool and determine what is the estimated fee rate. Okay, and they use that fee rate, and that amount of money is the implied difference, and then they see what amount of money is to be paid to the recipient, and the remaining, for the remaining, by default they'll create a change output which will come back to a change address of yours.
Exactly. So that is what you're saying, that depends on the wallet implementation.
Right. In the earlier days, this wasn't the case. Earlier days of Bitcoin, there was you had your own change output, but most modern day sophisticated wallets have a mechanism where they estimate their fees on their own, and they take into consideration the amount of bitcoins that you want to spend, and then whatever is the surplus amount, they will by default create a change address which will be different from your spending address, and that money will come back to you.
Okay, great.
All right. Okay, what next can we take? We can look at the next one, and then probably look at the wording documentation changes. Maybe one question. So this question is Bitcoin CLI list transactions fee amount is way off. Why? Our Chow notes this discrepancy occurs when Bitcoin Core's wallet is unaware of one of the inputs to a transaction but knows others, as in the example given in the question of a pay-join transaction. She goes on to note the wallet really shouldn't be returning the fee here since it can't accurately determine it. So I believe this is a user of Bitcoin Core that is estimating a fee, and the fee is erroneous. Okay, I'm using the default Signet network. My TX ID is this. Okay, so I believe the questioner is using the Signet network. This is a specific transaction that they are interested in. Okay, it shows a fee of this. So this is the fee that the wallet is estimating, when in reality the fee is this. Okay, in reality the fee is this. Now it is absolutely possible for your wallet to estimate a fee and that fee to be different from the actual fee. But this discrepancy, I feel, is too much. It is almost 2x, not even 2x. In fact, this is absolutely huge, because after the decimal, okay, and here we have 1, 2, 3, 4, 5 zeros. Okay, so it's an absolutely acceptable amount of discrepancy. Okay, what could be the reason? So the questioner is asking what could be the reason. I believe they're trying to make a pay join a transaction. Okay, so the answer is given by Ava Chow, who is one of the maintainers of Bitcoin Core. This occurs when one of the inputs is unknown to the wallet. For example, when participating in a multi-party transaction like a coin join, what happens is that the wallet checks to see how much value in the inputs it knows about. And if it is non-zero, computes the fee by subtracting the output values from it and then negating. The base assumption in this calculation is that all inputs in the transaction belong to the wallet. If any input is known, then the calculated input value will be non-zero, but all inputs must be known for this calculation to be correct. So what's happened here is that your transaction has two inputs, one of which is known, one not. The known one appears to be the second input of 0.003, taking that as the input value. 0.003 minus 0.008967777, which is this figure. Okay, it is negative, but the fee is always like positive. One thing to notice here is that the fee is given as a positive number. However, the wallet is supposed to be reporting it as a negative number. This is an indicator of this particular issue. Okay, so what the answer is saying is that this is a coin join transaction, okay, where multiple inputs are controlled by multiple wallets. And when your wallet is estimating, at least when your Bitcoin Core wallet is estimating your fee puts in the transaction that is controlled by your wallet. So what the user is doing here is the user is trying to create a coin join transaction where some UTXOs or some inputs are controlled by users Bitcoin Core wallet, and some inputs are controlled by some other wallet, some foreign wallet that the user does not control, and the user's wallet does not have any information about those inputs. So what the user's wallet is doing is it is only taking into consideration the input that it is aware of, and that is why it is giving erroneous fee. So that is what the answer says. Okay, that erroneous fee that wallet is listing is because this is a coin-join transaction where some inputs are taken from the user's wallet and some inputs are taken from elsewhere, which the user's wallet is not aware of, and that is why the user's wallet is not taking those inputs which it is not aware of while estimating the fee, and that is why it is giving an erroneous fee estimation. This is what the answer is. So yeah, this was also pretty straightforward. Let's see if we can take one more. Let's take this one. What happens if an HTLC's value is below the dust limit? Okay. HTLC basically it's a hash time locked contract. This question is in context to the Lightning Network. We've not talked about Lightning Network at all. So let's take this one. Okay. So it's like an escrow account. The real world analogy would be that of an escrow account. Okay. So I mean, we all hopefully know what a dust limit is. Okay, so the minimum amount of value that the UTXO should have in order for it to be broadcasted and mined into a block, it should be above dust limit. So like different nodes can set a different dust limit. Okay, so any transaction is below that dust limit. Okay. I'm just giving an arbitrary number. Let's assume that dust limit is 10,000 sats. Okay, so if I'm running a node and I set a dust limit of 10,000 sats, any transaction that is below 10,000 sats, my node will not relate. So that's the dust limit. Any transaction which is below that limit is considered to be a dust transaction, a garbage transaction, which your node will not relay. Okay, so what if there is an HTLC? Okay, this is in context of the Lightning Network. What if there is an HTLC in the Lightning Network? Okay, your commitment transaction is also an HTLC on the Lightning Network. So what if there's an HTLC in the Lightning Network which is below the dust limit? What will happen? Okay, because you can't take this HTLC on the main chain because it is below the dust limit, so it will not get mined. So what do you do in such a situation? Okay, Antoine Ponceau points out that any output in an LN commitment transaction could have a value below the dust limit, which results in satoshis in those output being used instead for fees. Okay, so these HTLCs are basically known as trimmed HTLCs. Any HTLC on the Lightning Network which is below the dust value is known as a trimmed HTLC. What do you do with trimmed HTLCs? Those trimmed HTLCs are just given to the miners as fee. This might vary from implementation to implementation. I believe there's a specific implementation here, but I believe this might vary. The behavior might vary from one implementation to the other. Okay, but yeah, most popular implementations probably what they do is they just give it to the miner because it's so low in value that nodes will not relate. Okay, and it's uneconomical. The amount of fee that you'll have to pay to redeem those UTXOs will probably be greater than the value of the UTXO itself. So what do? You just give it to the miner, and the miner, because the miner is also getting incentivized, will be more luring and inclining towards mining your commitment transaction. So it's like a win-win for both parties. Output in a commitment transaction in context to the Lightning Network is the transaction with which you go back on the main net. Okay, so you initiate a Lightning Network with the transaction which is a funding transaction. Okay, and then you close that channel with the commitment transaction. You start a Lightning Network channel with a funding transaction, you close it with the commitment transaction. Any output in a commitment transaction, not only HTLCs, may have a value below the dust limit. Any output whose value would be below the dust limit does not get created in the commitment transaction. This has the effect of adding the output's value to transaction fees. As HTLCs in a second transaction, that would be created if any output of any second transaction would be below the limit. Payments below dust cannot be enforced on chain. Okay, we just discussed if the payment is below the dust value, it will not be relayed by the nodes in the first place. Note, however, it's the case for any uneconomical output, an HTLC output whose value is above dust but below what it would cost in transaction fees to claim on-chain is likewise unenforceable. So any HTLC on the Lightning Network's commitment channel which is below the dust limit will not be relayed, and it will be given as fee to the miner that mines the commitment transaction. So I guess this is what we had to cover for the Bitcoin Stack Exchange questions. There were 10. We tried covering 5 or 6. Less we won't be able to. We'll probably take a couple of notable code and documentation changes. Any specific questions pertaining what we covered in this specific section before we move on to the next one, or anything anybody would like to share? Cool. If nothing, then let's go to the notable code documentation changes. All right. So the first is Bitcoin Core PR number 29575. It simplifies the peer misbehavior scoring system to only use 2 increments. 100 points results in immediate disconnection and discouragement, and 0 points allowed behavior. Most types of misbehaviors are avoidable and have been bumped to a score of 100, while 2 behaviors that honest and correctly functioning nodes might perform under certain circumstances have been reduced to 0. This PR also removes the heuristic that only considers P2P headers messaging containing a maximum of 8 block headers as a possible BIP130 announcement of a new block. Bitcoin Core now treats all header messages that don't connect to a block tree known by the node as potential new block announcements and requests any missing blocks. So basically, peers on the Bitcoin network have scores allotted to them. Okay, so there are certain behaviors that if a node performs, it is considered to be a misbehavior. Okay, and it is discouraged by deducting points. And if the node is acting in compliance with all the rules and regulations and behaving good, then it gets a high score. All right, so when like this is basically how the topology in the Lightning network, because it's decentralized, right? There's nobody who has the authority to determine which node is a good node and which node is a bad node. But there are certain behaviors that were used to give a lot of scores to the participants or the peers on the network. Okay, so now what has happened is that this scoring mechanism has become bipolar. So either the node will have 100 score, okay, which means that it is behaving appropriately, or the node will have a 0 score, which means it is behaving inappropriately. The motivation, I believe, behind this is to ensure that there is firstly clarity about what is acceptable behavior and what is unacceptable behavior. Okay, so whatever behavior is acceptable should be 100. Whatever behavior is unacceptable should be absolutely 0, so that you don't put a certain threshold. You don't say that okay, you are allowed to misbehave to a certain extent. Okay, so you for one misbehavior you get like a deduction of 10 points. For second misbehavior you get another deduction of 10 points. Third misbehavior you get another deduction of 10 points. Okay, and then you reach a third certain threshold, after which you get banned or flagged. Okay, so if it's misbehavior, it should be prevented at the very advent of it. Okay, so like certain things which were considered as acceptable in certain circumstances are now completely considered as acceptable behavior, and certain things which were considered unacceptable are now completely unacceptable. So the node will have either a 0 point or a 100 point. Okay, so there's no gray, it's either a white or a black. So that is what this peer does. It kinds of amends or modifies the mechanism in which the peers were allotted scores on the Bitcoin P2P network depending on their behavior. Another thing it does is that it touches on BIP120. So I believe up till now what was happening is that when a peer queries other peers for headers, and if the peers send them headers which are ahead of 8 blocks, the recipient peer would not ask for missing blocks. Okay, so for instance, if your active chain tip is and you are asking peers for blocks and your peer gives you n+9 block, you will neglect that block and you will not ask your peer for the remaining 8 blocks. Okay, because that is too much in future. But now what happens is that even if your peer gives you a block which is at a distance of more than 8 blocks from your current active tip, you will still accept that and consider that to be a valid header, and you will ask the peer that has shared that header for all the missing blocks. These are the 2 changes that this specific PR makes. All right, let us go to the next one. This also has to do with Bitcoin Core. It's PR number 28984. which adds support for a limited version of replace by fee for packages with clusters of size 2, 1 parent, 1 child, including topologically restricted until confirmation, that is struct transactions, also known as V3 transactions. These clusters can only replace an existing cluster of the same size or smaller. See newsletter number 296 for related context. So this PR has to do with class mempool and package relay and truck transactions. Okay, and we have talked about all of these in detail in the preceding sessions. our Monday session that we are conducting right now. So broadly, there is an upgrade that is being considered for the mempool, where the transactions will not be arranged as ancestors and descendants. Rather, they will be arranged in the form of clusters. Okay, and they will be added to the mempool and kicked out from the mempool in the form of clusters. Okay, and what V3 transactions, which is also known as transactions, which also now Bitcoin Core considers as standard. So up till now, we know, especially those of you who are a part of the Mastering Bitcoin cohort, you all will come across the fact that transactions, what are a transactions version number? So transactions with versions 1 and 2 are considered as standard transactions, okay, as per the book, but now even 3. A recent PR was merged, so even transactions that have a version number 3 are now considered as standard transactions, and they are known as truck transactions or V3 transactions. And if you all don't know what's replaced by fee, it's just replacing one transaction with another transaction, having same inputs with a higher fee, okay, with a higher absolute fee rate and with a higher cumulative fee rate as well. So what this PR does is that you can replace one package with another package. Okay, so if you are relaying a transaction which has a very low fee, such that the nodes will not even relay it, but it has a descendant which has a high fee, and cumulatively the fee of the descendant and the ancestor reach the fee which is acceptable for them to relate, then both those transactions will be coupled in the form of a package, and they will be relayed as a package. So up till now, we were replacing individual transactions with individual transactions, but now what this PR does is that it gives us a provision of replacing packages with another packages. So one package with a certain amount of fee can be replaced with another package with a higher fee. The only caveat is that the package that is being replaced should be of the same size or of smaller. Is there anything else? One more maybe we can take before we wind it up. A small one. Yeah, we can take this one. Rust Bitcoin, if there are any Rust enthusiasts. Rust Bitcoin PM 2794 implements the enforcement of the redeem script size limit of 520 bytes for P2SH and of the witness script size limit of 10,000 bytes for P2WSH by adding fallible constructors to script hash and WScript hash. So there are certain limits, okay. Your P2SH redeem script, okay. So like for those of you who are not aware, you all will learn this in Mastering Bitcoin. What's a P2SH script? Okay, so the most basic, or that which is referred to as a legacy script, is the P2PK script. Okay, then there's a P2PK script where you hash the public, and there's the P2SH script where you hash the entire script. Okay, but while trying to spend a P2SH transaction, you have to send or furnish the redeem script, which is the pre-image of the script. Okay, the script before you hashed it. So the limit is that a redeem script before it is hashed cannot be more than 520 bytes. So if you have any P2SH transaction, it will only be considered as standard if the redeem script, that is the script before you hashed it, should not exceed 520 bytes. Okay. So this is something like a trivia kind of a thing, or did you know kind of thing. In a P2SH transaction, the redeem script is the script before you hash it. It should not exceed 520 bytes for the sake of standardness. Rust Bitcoin now used to enforce this. I believe it now enforces this as well. Okay, I think this is BIP 16 if I'm not wrong, and this is BIP 141 if I'm not wrong. I'm not certain about it. And the witness script size limit is this. Okay, so for the P2WSH transaction, this is the post SegWit transaction. The witness script size limit should not be 10,000 bytes. Okay, so both of these rules were implemented in Bitcoin Core, which is the C++ implementation of Bitcoin. The last implementation, I believe, was implemented only this and not implementing this, and now both are being implemented. We did 9.5. We've completed 1 hour, and I don't think any of the other coherent documentations would be appropriate for us to take, because it'll require for us to go through a lot of context. We missed the news article this week, okay, because again, I felt that it would not be appropriate to spend too much of time on this, because this is research specific to the Lightning Network. All right, so to understand this, we'll have to go into a lot of context. We'll have to understand how the Lightning Network functions. We'll have to understand what channel graphs are. We'll have to understand what channel capacity is. We'll have to understand what liquidity is. We'll have to understand how probing happens. We'll have to understand how how routing and pathfinding happens. Okay. And it wouldn't be appropriate for us to eat up a lot of time, but still I'll just skim through it. Okay. I'll just read it and try and summarize it at a higher level. Whoever is interested can go and read through the post. So Rene Pichard posted to Delving Bitcoin about estimating the likelihood that an LN payment is feasible given the public knowledge of a channel's maximum capacity but no knowledge about its current balance distribution. For example, Alice has a channel with Bob and Bob has a channel with Carol. Alice knows the capacity of the Bob-Carol channel but not how much of that balance is controlled by Bob and how much is controlled by Carol. Pichard notes that some wealth distributions are impossible in a payment network. For example, Carol can't receive more money in her channel with Bob than the capacity of the channel. When all the impossible distributions are excluded, it can be useful to consider all the remaining wealth distributions as equally likely to occur. That can be used to produce a method for the likelihood that a payment is feasible. For example, if Alice wants to send a 1 BTC payment to Carol and the only channels it can pass through are Alice Bob and Bob Carol, then can we look at what percentages of wealth distributions in the Alice Bob channel and the Bob Carol channel would allow that payment to succeed? If the Alice Bob channel has a capacity of several BTC, most possible wealth distributions would allow the payment to succeed. If the Bob Carol channel has a capacity of just barely over 1 BTC, then most possible wealth distributions would prevent the payment from succeeding. This can be used to calculate the overall likelihood of the feasibility of a payment of 1 BTC from Alice to Carol. The likelihood of feasibility makes it clear that many LN payments that naively seem possible will not succeed in practice. It also provides a useful basis for making companies. In a reply, Pichard describes how the likelihood metric could be used by wallets and business software to automatically make some intelligent decisions on behalf of its users. Okay, so the point being, on the Bitcoin network, if you have a UTXO and you want to send it to a certain person, okay, as long as you are acting within the consensus rules and the policy rules, there is nothing that can prevent you from doing that. Okay, so if Alice has 1 Bitcoin and Bob has, and she wants to send 1 Bitcoin to Bob, okay, there's nothing that can prevent the two of them from sending and receiving that transaction as long as they're complying with the consensus rules and the policy rules. But the Lightning Network functions a little differently, okay, because in the Lightning Network, you have to route payments. If we don't have a direct channel established with the recipient, you have route payments. Okay. Now, when you route payments through multiple channels, you have to ensure that all the channels through which you route payments have adequate liquidity. Okay. So if Alice has a channel with Bob and Bob has a channel with Carol, and Alice wants to send some money to Carol, Alice will first send it to Bob and then Bob will send it to Carol. Okay, so the channel between Bob and Carol, Alice knows what's the liquidity and the balance distribution in the channel between Alice and Bob, but Alice does not know what's the channel distribution between Bob and Carol, right? There's a difference between channel distribution or the channel fund distribution, the capacity of the channel. The capacity of every channel is known to the entire network. The capacity of all public channels are known to the entire network. Okay, so if Alice sets up a channel with Bob, Alice will announce the capacity of that channel. Okay, that capacity is known to the entire Lightning Network as long as it's a public channel, but the distribution, okay, the distribution is not known. So let's say the capacity is 1 Bitcoin. Okay, everybody knows the capacity is 1 Bitcoin, but then Alice sends 0.1 Bitcoin to Bob. Okay, so now the distribution changes. The distribution is now Alice 0.9, Bob 0.1. That is not known. Okay, the wealth distribution within a Lightning channel is not public information. It is private information. It is only the participants in that Lightning channel that have that information. Okay, for confidentiality reasons, obviously, you don't want everybody to know what payments you're making, right? Otherwise, there's no reason of having a decentralized network, right? One of the primary motivations of having a decentralized network is to ensure financial privacy so that nobody knows who is making what payment to whom, right? So on the Lightning Network, if every time I make a payment, that the entire network knows who's the sender, who's the recipient, then the entire purpose is defeated. So you know the capacity of a Lightning channel, but you don't know the channel balances. You don't know how much amount of funds are controlled by which channel participant. So when you want to route a payment, okay, if I want to route 1 BTC, I am Alice, I want to route 1 BTC, I want to give 1 BTC to Carol, okay, I need to ensure that first thing I need to ensure is that the channel capacity of Bob to Carol is 1 Bitcoin. Okay, if it is less than 1 Bitcoin, then I cannot route that payment. The second thing I need to ensure is that Bob should also have at least 1 Bitcoin. Okay, because it's Bob that's going to pay Carol. I'm going to pay Bob. Bob is going to pay Carol. Okay, so if I give Bob 1 Bitcoin beforehand, Bob should have 1 Bitcoin to give it to Carol. Okay, how do I find that out? Because I don't know the exact channel distribution. That is private information. I know that Bob has a channel with Carol. I know that channel capacity, the cumulative amount of capacity in that channel is 1 Bitcoin. But out of that 1 Bitcoin, I don't know how much Bob owns. I don't know how much Carol owns. I can just guess. Okay, I can just route a payment. If Bob has 1 Bitcoin, the payment will go through. If Bob doesn't have 1 Bitcoin, payment will fail. Then I'll probably find another channel and try and route the payment. Then it might fail. So like you know, it's just trial and error. The Lightning. Okay, you input paths through which you can connect to a recipient, and you just do trial and error. Okay, there are certain algorithms in place, but more or less it's trial and error. You just keep routing payments till it eventually reaches the final destination. All right. So what motivation of Freddy Picard is here is to optimize it, right, without knowing exactly how much channel balance Bob owns and how much Carol owns. Let's come up with an algorithm that can estimate and give us an overview of whether this payment that we are trying to route from Bob to Carol will succeed or will it fail. Okay, so whoever wants to dig deep into how exactly comes up with that algorithm, how exactly he goes about his approach, can go to this Delving Bitcoin post and read it. And here he has a link to a Python notebook where you can go and read some code. I believe in here is also a lot of other links where he shares what research he's been doing for the past, I believe, a couple of years at least. Okay, so the gist of this is that you know the channel capacity of a channel on the Lightning, but you don't know the distribution, the actual amount of fund that each part of the Lightning channel. Okay, it's very important for you to know to route a payment successfully. But if you make that information public, then there is no privacy in the Lightning Network. So you have to keep that information confidential. At the same time, develop algorithms that can make it a guess, that can make an estimation about how much funds in a Lightning channel who controls, in order to make the failure rate of Lightning payments less. So this guy is working on that. Anybody who's interested can go through and read his research paper. That's what I had to share in the Bitcoin Optech newsletter for this week. If anybody had questions, any thoughts, any anecdotes pertaining the newsletter, or anything else that you all want to share about the world of Bitcoin, anything new you read about, anything you're curious to share with fellow Bitcoiners, we can hang out for 5-10 minutes and you all can speak. And okay,